Hello everyone. Today we're going to be proceeding with our study on multiplication. In some of my previous videos I showed you that you can multiply by making uh, rows and columns of different squares, and that's one way to think of multiplication. Today we're going to be getting a little bit more abstract, which is going to help us when we eventually get to algebra. So without further ado, let's get started. So I have here as an example this multiplication problem, 73 times 86. Now, one of the ways that we can understand this is by creating a rectangle where we are planning to have 73 lines going up and down, 73 columns, and 86 rows. Now these could be swapped around. 86 could be here, and 73 could be here. It really doesn't matter. However, that's how we're going to understand it. Now, as mathematicians, we're really not interested in following the exact process every time. If there is a way that we can still understand what we're doing without having to do all the work that goes into it. So what I mean is, I could go in here and draw 72 lines, right? And that will make 73 columns. So I could go in there and do that, and then draw, so that we have 86 rows. But that's a lot of copy pasting and just making all these rows, and then I have to count up each of those individually, and that's a lot of work. Now, for a beginner, someone who's just still understanding the concept, that might be what you have to do. But if you're already familiar with that idea, and you kind of know what your process is going to be, we can work with the understanding that things are going to count like we did draw them, but we're not actually going to draw them. And that's going to save us a lot of time, and it's going to make things much more efficient. And that's how you start getting proficient with mental mathematics. So you start by actually considering, drawing them, and if you're really a beginner, you actually draw in all the lines. And then as you proceed, you say, well, maybe I don't have to draw all the lines, because I can just either imagine what it looks like to draw all the lines, or I know that the lines are there and I don't have to draw them because I know what I'm going to do anyways. Right. What I've done here is I've re-represented, so I had here you saw before it was 73 and 86. What I've done is I've represented us breaking up the rectangle just like how we would do in a previous video where we actually drew in all the rows and columns. But since we realized, maybe we don't have to draw all the rows and columns, that means that we can speed things up. So instead of having 70 and then 3 as rows, I'm just having a block which represents 70, so it's abstract. It's just a representation. We understand that this means 70 columns, and that this represents 3 columns. So together that's 73. And then we understand that this represents 80 rows and 6 rows without actually having to draw them. There's that understanding of what those represent. So we can now just multiply these. If you're familiar with 7 times 8, right? 770 times 80 becomes 56 times 100, or 5,600. Then 3 times 80 would be 240. And then 70 times 6, that's going to be 420. And then 3 times 6 is 18. So I'm going to go ahead and add those in there, and I'll be right back. So here, I went ahead and filled in each of these spots, and as you can see, we just add these up and you get the multiplication. We get the product. here, 6,278. And that's 73 times 86 is 6,278. So this model that we can use, this representation of multiplication that we use, is one of the representations that really lends itself to understanding algebra. And what's really great about this is that you can break up these numbers in any way that you like. So depending on which numbers you're good at multiplying, or if you're more comfortable multiplying different numbers, you can totally just break these up separate, and I'll give you an example of that in a minute. But also, this begins to build up this idea, right? 73 times 86 is the same thing as 70 plus 3, and I'm putting them in parentheses here. So you take 70 plus 3 times 80 plus 6. And the reason I'm putting this here is because this format right here, and usually we don't put the x in here, we just put it with parentheses like this. So 70 plus 3 times 80 plus 6. When you see a multiplication that follows this format, you can think of it in this format as well, right? So all of these are connected, and it would really help, especially as we move on into algebra, if you understand that this means the same as this means the same as this, you know, as the number of columns, or vice versa, you know. So all these representations are connected together, and you can use them flexibly. So I said I was going to give you an example, and I will do that. I'll be right back. So in this example, this is a different example. We're doing 29 times 51. And you can see here, I broke it up in a manner similar to what we did before. So we've got 20 plus 9 times 50 plus 1, right? 29, 51, and then we can multiply it that way. So you can break it up this way, and that works really well if you're okay with, you know, 9 times. If you're really familiar with your 9 multiplications and you've got them memorized and you remember them all, then that might be really helpful. But sometimes it would be more some people, you know, they think differently, and so 29 is not really easy for them. So another thing you can do is, instead of thinking of 29 as 20 plus 9, you can think of it as 30 minus 1. And so what that allows you to do is, it allows you to take that 9, right? So that 9, which is really kind of on the harder end, quote unquote harder end of multiplication, and it allows you to turn it into this -1, this -1. And 1, a lot of people find a lot easier to multiply than with 9. So I'm going to change this picture. I'm going to leave this here so that you can see that the answer is still the same. But I'm going to change this picture to symbolize, or to represent, this new representation here. All right, now you can see that I've got a -1 here. That's because 29 is 30 minus 1. Right? These are actually the same thing. So 30 minus 1, I can put 30 and then -1, and we'll still get the same answer. So 30 times 50 is 1500, which I also put here. Okay, I remember I saved this line from before. And we've got -1 times 50, which is -50. Right, there's your -50. We've got 1 times 30, which is 30. And then 1 times -1, which is just -1. So what this is really doing is, it's giving you an explanation picture-wise, but I want you to understand that this picture is optional. So when you're doing this mentally, you're actually jumping straight from here you're skipping this, and you're going straight to building these. Okay, and you're mentally able to just start building these one at a time. When you get to algebra, understanding these concepts, these visuals that you may not be using, but if you can at least understand them, it can then help you to understand how algebra works. Because what algebra is going to be doing is just another level of abstraction. So you're just taking away even more. So you started with squares in a rectangle, then you took away the actual rows and the columns, and then you were like, okay, well, I'm not going to draw the squares, but I know that they're represented. And then algebra just removes even more. It says, well, I know that you actually take away the numbers, and you say, I know that the numbers, I'm not going to actually write the numbers, but I know they're there, and I know they're represented. Anyway, you can look forward to another video about that. Have a wonderful day, and I'll see you later.